Whoa, the GOAT is back. The GOAT, the greatest of all time. You know what I'm saying? The African greatest of all time. I'm a great. Yo, so it's a FaceTime. If you FaceTime my channel, right? You know what to do. Just go and subscribe, share to a lot of people. My name is Hamish, but a lot of people call me 25 bacteria, the Nile River soldier. You know we can brag, can rock, can get distinction all the time. Know what I'm saying? 100%. Let's get started, man. So they say show that the root of x squared plus kx plus k minus 1 are real and rational. Oh, what is rational, man? So rational, if somebody give you rational, like if somebody give you 2/3, that's a rational number. Or in number, as far as fraction. 3, this is rational? Yeah, you can write it as rational because I can say this 3/1 because 3/1 is still 3. A/b, yes, it's rational. You know what I'm saying? Okay, if somebody give me this, yeah, I can change this to rational because square root of 25 is going to give me 5/3 and it's rational. It's rational. Okay, how I'm going to know something is irrational? So irrational is like, let's say you have pi. It's not rational. I'm saying because pi is like 3.1. Bigger numbers is not rational. Pi is not rational. It's irrational. Okay, somebody give you square root of 3/5. You see, that's not rational because it's not rational. It's not. So those are type of irrational. So now let's say show that the root of. Okay, let me explain to you something quick. This is very important. If you have in quadratic, right, like general formula of quadratic, we say x equal to negative b. Okay, so let's say our b equal to 5. Let's assume, and then plus or minus square root of b squared minus 4ac. Okay, so now here, let's say you got b squared. Let's say b is 4, so it's gonna be 4 squared equal to 16 minus 4 times a. Let's assume our a equal to 1 times c. Let's say c equal to 4. You know what I'm saying? And this b equals 4. Okay, b equals 4. And then over 2 times a. Let's say equal to 1. Like this. Let's say they give a quadratic like, okay, let me write here something. Okay, so x squared minus 4 times b equals 4. C plus 4. Excuse me, stuff like that. So what happened now? So if you take this, look, what is your b? B equal to negative 4. And then plus or minus b squared means negative 4 squared equal to 16 minus 4 times a equal to 1 times c equal to 4 over 2 times 1a. So now if you have this situation, so now this is gonna give you means this is gonna be 16 over minus 16 equal to 0, square root of 0 equal to 0. So now this is gonna give me my answer, which is answer sometimes we can call root. So the root of this quadratic, when you square root 0 equal to 0 over 2, means it's gonna give me a rational number. You know what I'm saying? Because it's going to be negative 4 plus 0 equal to negative 2. But negative 2 is like saying negative 2 over 1. And negative 4 minus 0 equal to negative 4 plus 0 equal to negative 2 over 2 equal to negative 2 over 1, which is rational. But not all the time you might get rational. Sometimes if you have here in square root, let's say you have in a square root stuff like, excuse me. Let's say here inside we have, let's just say this is 1. Let's say c equal to 1. And this is going to be 1. So what you going to get? 16 minus 4 equal to square root of 12. So this is going to give us 4 plus or minus square root of 12 over 2. So you see, this is irrational. You know what I'm saying? This is going to be irrational. You hear what I'm saying? So this is going to be irrational because you see there's a problem, irrational. Okay, well, so now we know how to determine when you have a quadratic irrational and irrational. So sometimes they're going to ask something about the real root. So for whenever you want to have a real root, you must have this condition. B squared minus 4ac, it must be greater than 0. Greater or equal to 0 for real root. You know what I'm saying? For real root must be greater or equal to 0. It's for real root. And for unreal or non-real, or aka unreal, the space not enough, you say b squared minus 4ac is less than 0. So now, for this case here, they say show that the root means when you solve this means the root is like an answer for it. Like, it's going to be real? Oh, it's going to be real. Which condition are we going to use? Means we're going to use this. And also at the same time, it's going to be rational value of k. Oh, rational and no rational. Oh, okay. So now what I'm going to do, I'm gonna write my condition that would b squared. So b squared, let me rearrange this. So if I arrange this as quadratic, you know quadratic, it always has to be in the form of ax squared plus bx plus c equal to 0. You know what I'm saying? Equal to 0, right? So now, my ax means this 1x. bx means this is b and this is x. My c is this stuff here. That's my c. So now I'm going to place them in here. B squared, what is my b? B equal to negative k. So negative k, what? Square minus 4 times a. What is a? A equal to 1 times c. C equal to k minus 1. So now, you know what I'm saying? So now we say that for this condition, for this to be, how do I say here, excuse me? Real and rational. So to be real, one must be greater or equal to 0. So it means this must be greater or equal to 0. You know what I'm saying? Okay, greater or equal to 0. You know why? No, let me come back here. So we say here, this stuff here is like, look, let me write here. Okay, so it was negative b plus or minus. I'm going to write the same thing here. It was 16 minus 16. You know what I'm saying? Like, this one here is in a formula, it's like b squared minus 4ac, or formula of quadratic. So negative b plus or minus over 2a. So this stuff here means this, if it's equal to 0, remember we get irrational because everything is going to be 0. So either all this stuff it can be equal to 0, because it's going to be negative 4 plus 0 over 2 means it's irrational. You know what I'm saying? So it must be equal to 0 and it must be also greater than 0, because if it's less than 0 is the problem. You know what I'm saying? What a problem, because we cannot square root a number which is less than 0. Means anything inside the root, if it's less than 0, let's say what we had here, just let's say it's not 0, let's say negative 3. Means b squared minus 4ac is going to give us what? Unreal, because we cannot square root a negative number. That's what unreal, but it's not for this question. So for this question, they talk about the real roots and it must be rational. So to be rational means it must be, this stuff, whatever it must be here, it must be equal to 0. Or it must be perfect square in other way. Because even if you have, let's say, square root of 25, and here's negative 4 plus or minus, this also is going to give us rational, because it's going to give us negative 4 plus or minus 5, because square root of 25 equals 5 over 2. So it also was going to give us a rational if this number is going to be perfect square. So either it must be perfect square or it must be 0 for rational. But for real, it's not a problem, you know what I'm saying? But okay, so now let's see if this is going to be perfect square. So the outer condition for real root, it must be greater than 0. Okay? But for rational means it could be negative 4 plus or minus even 81. It's not 81 is not equal to 0. Let's say over 2. Okay. But since it's the perfect, then cool. Negative 4 plus is going to be plus or minus what? Square root of 1 equal to 9 over 2. So you see this is rational because negative 4 plus 9 equal to 5, 5 over 2 equal to 5 over 2 rational. Negative 3 minus 1, negative 4, negative 13 over 2 rational. You know what I'm saying? So for real root it must be greater. It may greater or equal to 0, but for rational it must be perfect square, because if this is, let's say, 31, it's not rational, so that's irrational. So they might ask you sometime. Okay, now let's try to break this down to see if it's going to give us perfect square. Sorry about all this mess here. And so that you can try to erase. Thank you for your patience. Everybody, I beg. Yes, everybody, I beg. It's not I'm back. I beg. Okay. That's me when I was begging, man. When I was bad, but I don't know how to talk. Okay, cool. Now we go. It was greater than 0, right? Yeah, it was greater than 0. Now let's check for perfect square. Now if it's going to be perfect square, now we say okay, so negative k square equal to k square. Now this one you multiply is going to be negative 4 times 1, 4 times k, negative 4k, negative 4 times negative 1 plus 4 greater equal to 0. So let's check. So this is for real root. Now let's check for rational. For rational it has to be perfect square. If it's not perfect square means it's irrational. Now let's go. So this is same as say to get k square this must be k, and to get k square this must be k. And to get 4, this must be 2, and this must be 2. So the middle number is negative, this must be negative, and this must be negative. When you multiply, this is going to give us k minus 2 square greater than 0. So since the perfect square, see this is a perfect square, when it comes like that, then is rational. But if it was not perfect square, let's say it was 3 here, then you could have say is irrational. Now I'm saying, so since it's perfect square, so I'm gonna say if it's perfect square and is greater, so it's perfect square is for rational. You know, like I say here, I think you saw there, like if I have 25 square root plus a number, it's going to give you rational. So this is for rational. And then for greater than 0, for b square, means for this is greater than 0, for b square minus 4ac greater or equal to, or just greater than 0. And then we know that is for real roots. So this is for real root. But if it is less than 0, we say what for? Non-real. And if it's not perfect, it's for irrational. So you gotta keep that in mind. This is very, very important concept, baby. So now let's go for the next one. So that one we done. Show that the root of quadratic, so here's where you stop. This is your final answer. And then you can write this perfect square, rational. This is greater than 0, greater than 0 for real root. So other way around, if it's not perfect square, like x minus 3, and then let's say x plus 2. So we know this is not perfect square. Because perfect square means the same thing times the same thing, like here. Same thing times the same thing. Oh, okay. So this is irrational. Irrational, and if it's less than 0, means this stuff here is unreal, or non-real, or non-real, baby. So now we're done with the first part. We go to the second question. Oh, so face, man. I gotta drink some water. Okay, we're done with this. Yeah, we don't need this. Okay, cool. Excuse me, just wanna dry a little bit because where's my tissue now? I can't see my tissue. Where is my tissue, baby? Where is it? Where is it? Okay, it's fine. I'm gonna find it. So, okay, let's go. I'll get in the way. Okay, cool. Now we go for the next one. So given that, so if somebody give you this now, let's say you don't know, because for now, like they even tell you, they make it easy. They say, oh, there's a constant second difference. So if there's a constant second difference, oh, this is quadratic sequence. But if they don't tell me, I'm gonna test. I'll test for geometric, I'll test for arithmetic, and I'll test for whatever. Okay, you know what I'm saying? So since they say take second common difference, oh, I know this is gonna be quadratic sequence. So I'm gonna write my number, which is 0. Okay, I got my -1, and then I got 1, I got 6, and I got 14. Now, -1 minus 0, -1. Okay, this is gonna give 1 minus 1. It's like 1 minus -1 equal 2. 6 minus 1 equal to 5, and then 14 minus 6 equal to 8. Okay, so now let's do the second one. So now we go, oh, next minus previous. 2 minus -1 equal to 3. 5 minus 2 equal to 3. 8 minus 5 equal to 3. Oh, so our common difference equal to 2. The second difference, the second or constant second difference is equal constant common difference equal to 2. Now let's say write down the next term of the sequence. So this is like constant next term of the sequence is easy. So either I can skip this one and then I can go for this. Or I can just write, but later I'll come back and make sure it's the same or write constant difference. Okay. So for me, I'm gonna say, okay, if this is 3, this also must be 3 here. Okay, let me write down D here. So this is going to be 3 also because the constant second difference is same. Okay, look, how did I go here? They say this and this means -3 plus, they get 2. 2 plus 5, 5 plus 8, this plus will be 11. Now we come here. How did I get this? Look, 0 plus -1, -1. -1 plus 1 equal to 1 plus 5 equal to 6. 6 plus 8 equal to 14. 14 plus 11 equal to 25. So the next term of the sequence equal 25. But I'm gonna come here, I'm gonna do it, and then I'll test using my formula, man. Yes, let's go, baby. Now, determine the expression of the nth term. Oh, so the one Tn for quadratic sequence. We know this, man. This is Tn equal to n squared plus bn plus c. Find a, b, and c, and that's the expression they're looking for of quadratic. Can't you see it look like quadratic? Oh, yeah. Now, how are we gonna get a? Oh, we know 2a always from here to A equal to the second common difference. Oh, we know all the formula. We can write here 2A equal to D. Now the second say 3A plus B equal to the number that you get here. This number, which equal to -1. And then A plus B plus C, A plus B plus C equal to this number you get here, which equal to 0. Okay, cool. Now let's go, man. So plug it in and let's get it done. So we know A. What is our D? D equal to 3. So A equal to 3 over 2. Because this D equal to 3. So over 2 over 2. Okay, so we have our A. So if you got A, then we can use this to get B. Let's go. So 3A plus B equal to -1. 3A plus B equal to -1. Okay, A we know. So 3 times 3 over 2 plus B equal to -1. Okay? Now, how are we going to get that? So we know 3 times 3 equal to 9. 9 over 2 plus B equal to -1. So this is, you go over. So this is equal to our B equal to -1 plus 9 over 2. By -1, I look at the denominator. This is 2. Or you can plug in the calculator, but for me, I can just do the head. So I said this equal to negative. By -1, I look at the denominator. This is 2. So here I'm going to write -2, 2. Because I want the denominator to be the same because it's going to save my life. Because here is 2 and here I'm going to write 2. So, and then I'll see to get -1 means this must be 2 also. So the denominator is the same, so write only 1. Now -2 plus 9 equal to 7. So this is 3.5 or 7 over 2. 3.5 or 7 over 2. Oh no, I think it's a math mistake here, man. Look, when this one go over, it's going to become negative here. Minus, so this must be minus, so this is going to be -11. -11 over 2, so -11 over 2. So we have an A, we have a B, so, okay, B. Now we're going to get a C. I'm going to use that formula. A equal to 3 over 2 plus B. What is a B? Our B equal to plus minus 11 over 2. And then plus C equal to 0. Guys, take this together. So the denominator is the same, I'll get 2 here, and then 2, 3 minus equal to 80. So 8 over 2 equal to 4. So here is equal to 4 together. Plus C equal to 0, so C equal to -4. So my C equal to, I made a mistake, look. This is -4, because look, denominator the same, means I write 2, means 2. And then I come here, 3 minus 11, -80, and this is equal to -4. So this -4 go over, it's going to become +4. So C equal to +4. So for that case, I'm going to take that and substitute here. And get that expression of quadratic sequence. So now, let's make a space here. Oh, okay, just come here. And we know A equals 3 over 2. So I'm going to say Tn, the expression we're looking for, equal to A. A equal to 3 over 2. And square. Plus B. What is a B? Our B equal to -11. B. B equal to -11 over 2. So plus minus 11 over 2. And C equal to +4. And this is our expression that we're looking for. It's a math expression in the nth term of this sequence. You know what I'm saying? Of this quadratic sequence. Calculate the 30th term. Come on, man. Come on, baby. 30th term. Easy. So I'm going to put here 30. So say 10, 30 equal 3 over 2. 30. Yeah, 30. 30 square minus 11 over 2. 30. Plus 4. So plug that in the calculator. Check my calculator quick. Plug in the calculator, and that's going to give you 1189. This is going to give you 1189. Okay, 1189. So the 1030 equal to 1189. So I'm going to raise, we done. And that's how you do with the greatest of all time. Easy, man. Let's go. So now we go to question number 2.2. So let's say the arithmetic series. So we don't know. Oh, arithmetic, correct. Excuse me. We know exactly. Why do I say we don't know? We know exactly it's arithmetic. So for that case, easy. Say prove A equal to 6 and B equal to 20. So it's arithmetic. And if I take this amount of this, it must be equal to this amount of that. Okay, cool. Now let's go. So I'll say, so since it's arithmetic, I'll say 13 because we know to get common difference. I'll say 13 minus A. It must be equal to 27 minus B. Okay, now this. Okay, how did it say here? Whew. Why it's like it's not coming here, man? Come on, man. Okay, cool. We're gonna get it. Okay, so now we say Okay, cool. Now let's go. So prove that A equal to 6. Okay. So that's gonna give me common difference. And if you can give me that common difference, and I got it. Okay, cool. Now let's go. Just thinking, just a second. Okay, cool. Now let's go. Let me see. So we say this minus this. Oh, I think I forgot something. A, what did I do here? I'm wrong, man. This is very wrong. Excuse me. Because it must be next minus previous, 13 minus A. 13 minus A. It must be equal to B minus 13. And it must be equal to the 7 minus B. So I can equate whichever one. So I want to see which is going to make my life easy. Let me start with this first. Because this is going to help me to get B. So I'm going to take this one first, and then maybe I can take this and that. Because this can be equal. Like, you can equate this and this, or however you want, because all of them are equal. I'm going to start with this because I know this B is going to come over. So it's going to be B. This B is negative, going to come over, is going to become positive and equal. This is 27, and this is negative 13 is going to go over, it's going to become positive 13. So 2B equal to 40, so B equal to 20. Now I'm going to take this and this to get A. So I'm going to say 13 minus A equal to B minus 13. So we know B equal to 20, so this is 20 minus 13, and 13 minus A. I'm going to get A. This is going to give us 7, and this 13 minus 8. So this is negative, right? I'd rather take 2. I hate negative, man. Negative, I hurt you. So this is going to go over. Woo, woo. A positive, and this is going to come 13 minus 7. 6 equals to 8. So A equal to 6. Oh, we got it. Yeah, we proved it. Now, we go for the next one. Which term of the series is going to be equal to 230? So first and foremost, I know my A. So my A equal to 6. So I can write here 6 means first term, because I know whichever formula I'm going to apply, I'm going to use A. Okay, my B equal to 20. Which term of the series is... so we know this is arithmetic already. So which term of this... Which term? Oh, so for arithmetic, Tn equal to A plus N minus 1 times D. Some people write D before, D after. It doesn't matter, as long as give it the answer. Okay, so they say which term means we're looking for N. Of the series which equal to, means this is Tn. Means, now we have a 230, but we don't know like which term equal to 30, because this is term 1 equal to A, term mean term 2, term 3. So which term equal to, so this is Tn, so this is going to be 230 equal to A, our A equal to 6. Plus, we don't know, we're looking for there, our common difference is 13 minus 6 equal to 7. 20 minus 13 equals 7, 7. Or you can write here before. Me, I like to write before, but a lot of people, a lot of books, they like after. Whatever you want. So now this, I'll take 6 over, so 230 minus 6 equal to 224 equal to N minus 7. N minus 1, 7. You can multiply all, but me most of the time, like I always tell you, I treat this as a one number, so divide by 7, because like this all, whenever I have a bracket, I treat it like, it's one number. So divide by 7, divide by 7, divide by 7 here, divide by 7. This and this goes. So how many 7? 22. Yeah, 3. I'm left with 1. So this is 14. How many 7? 14. 2 equal to N minus 1. This minus come here. I hate you, negative. 32 plus 1 equal to N. So N equal to 33. So which term? So term 33. Which term? So you say term 33. Yeah, 33 equal to 230. Term 33. N equal to 33. So N equal to 33. So since they say which term, I'll say term 33. You can write the word term 33, or you can say T33 equal to 230. However you think is going to be convenient for you, you do that. Now, this is very, very important here. Let me show you something very, very important. This concept, what we're doing right now. Let me make a space here. Show you something here, very, very important. So now note, for anything to converge for geometry, this is most of the time for geometry, your common ratio has to be between -1 and +1 for convergence. For any convergence, your arithmetic series whenever you have, it must be positive 1 and negative 1. For convergence, memorize this for convergence. Means your common ratio must be between negative 1 and positive 1. And there's something, means your series or your sequence does converge. So sometimes, like for example, somebody give, let's say, a series of numbers. Let's say, let me say 3, negative 9, negative 27. Positive. Does it converge? So now you come here, what you do, you look at common ratio. Now take next so 27 divided by 9, negative 9 equal to negative 3. And this is going to give us negative 3. So our common ratio equal to negative 3. No. So since your common ratio is not in a range of positive 1 and negative 1, because it's not in between. That's why I wrote this and then I cut it. So the series or the sequence is not converging. It's not. So sequence is not converging. Not converging. In other words, it diverge. Converge is like in between, like in here, we converge each other. You know what I'm saying? So now, or if you don't want to do this, say if since negative 3 is out of range of common ratio, which is negative 1 and positive 1, then it does not converge. It does not converge. Does not converge. So sometimes they don't give it in terms of number, they're going to give in terms of letter. So this is what you're going to do. So I would say, okay, I have to get common ratio. How am I going to get common ratio? Next, because they say this is not geometry. This, even by looking, if they don't tell me, look, if I take this divided by this, it's going to be the same as this divided by this. How? How did you know there's a lot of case there? Look, man. If somebody gives you same thing and the same thing square and same thing cube, we know for a fact. If I take x squared divided by this, it's going to give me x. If I take x cubed divided by x, it's going to give me x also. So we got the same common ratio. So it's not necessarily must be like x squared. Look, this is the same thing. Treat a bracket is the one thing. So it's like y power 1, y power square, y power cube. Here, this is cube, I made a mistake here. My apology. Oh, so if I take y square divided by y, it's going to give me y. This divided, you give me a letter, you know what I'm saying? So, you know, oh, so for me, I'll say this divided by this, look, 1 minus k power 5 divide by 1 minus k power 5. Look, this and this is going to cancel. So, even when you take this and this, mean this power 3. So 1, so we're going to relate it to 1 minus k over 5. Look, 1 minus k over 5 power 3 over 1 over k, 1 over 5, excuse me, 1 minus k power square. So you see, 2 and 2 is going to cancel, so left to 1 minus k. So they all have the same common ratio of 1 minus k. Okay? 1 minus k. So for that case, your common ratio, you gotta show this in exam, right? You can even say a common ratio equal to. So my common ratio, so you say here, they say show if this is going to converge. So say for convergence, you can say for convergence, we know for facts, you gotta copy this, right? This is a very, very important concept. You're gonna do this until the end of your math. I don't know when. For convergence, you know, common ratio, it must be between negative 1 and positive 1. So now I don't know my common ratio. I want to know right now. Tag this, plug it there, baby. So this is gonna be 1 minus, plug your common ratio, minus k over 5, and then plus 1, and this minus 1. But not. I want to show you something here. In inequality, if somebody give you, let's say 2x minus, let's say, plus 4, and let's say they give you this 5, let's say solve the value of x, let's say here 2 or 1, it doesn't matter. So what I'm going to do to solve x here, I must take this out because I need x alone. So this is going to come over, so it's going to be 5, this positive when it comes is going to be minus 4, it's how you go. Here I'm going to be left with negative 2x, but whatever you're going to do on the left, you must do also this side. So this 4 is going to go over also, since it's positive, it's going to become negative. It's going to be 2 minus 4. So this is going to give us negative 2, and this negative 2x, that's equal, and this equal to 1. So you see, I want to get x. So remember, in inequality, whenever you divide by negative, the direction of inequality change direction. If you have negative 3x equal to, let's say it's greater than 9, if you divide by negative 3, divide by negative 3, this and this cancel, so x is going to be greater And means the moment you divide, only when you divide by negative, the direction of inequality change. So here, since I want to get the value of x, I'll divide by -2 throughout. Oh, so this formula is going to give me -2, but the direction is going to change. It's going to be this way. And here, -2, -2, go. And now, it's going to give me +1, but direction is going to change. Oh, so this is my final answer. Or if I don't want, I can just switch everything. Okay? So how I'm going to switch these, man? It's easy. So what I'm going to do, I'm going to start with this, because it's always good, yo. Quite like this. It's always good to look this way. Not all the time, it depends on the question. So I'm going to start first. I'll write my 1 and then I'll look, okay? Look, I'm going to write my 1. 1 first means 1, and then I'm going to look where. You see this thing? It's like, you know when you're young, like when you play whatever, if you go, you play netball, or when you boy, you play soccer, or rugby, or ball. Don't touch me. So this thing here is facing down the 1. Means it's facing down the 1. And then we got x. Now you go here between x and a half. This thing is facing on x. Means it's going to face on x. And then -1/2. So you can write like this too. Same thing. This is a good way. But after you finish. Oh, so now I'm going to come here. I'll do the same again. But first and foremost, I don't need this 5. So this 5, I'm going to multiply by 5 throughout. Multiply by 5 means multiply here by 5. And multiply here by 5. And also here also by 5 everywhere. So 5 and 5 is going to cancel. So 1 minus k greater. This is equal to 5. And this is equal to -5. So now 1 is going to go. 1 and 1. So this -5 minus 1. -6 less than. And this is going to be it's going to be 5, and this positive minus 1 equal to 4. Okay, 4. And then after that, raise here a little bit. And then after that, we left with negative k. So since I want to get the value of k, divide by -1, -1, -1. So this is going to give us +6 less than k. Oh, direction must change, man. -4. So after that, oh, don't touch me. I'll start to this -4. Okay. Start to the -4. Face -4. I like this stuff when it's facing this way. So this is going to be facing -4. Face down -4. And then k. See k? This stuff. And then this between 6 and k. This thing is facing on k. And then we got 6, so you can write like that. So that's our final answer. So now we go for 2.14. Let's just try to make a space here. Okay. Let me drink your water, guys. Just a second. Drink your water, babe. Drink your water.